Welcome to the DIY Honda Garage channel. The DTC P16E2 or PGM-FI-ACG LIN communication error specifically relates to the communication malfunction between the Powertrain Control Module, PCM, and the alternator via the Local Interconnect Network, LIN. This error indicates that the PCM is unable to receive critical signals from the alternator, leading it to conclude that an abnormality exists in the system. The alternator plays a vital role in charging the car's battery and powering electrical systems when the engine is running. It is located usually at the front of the engine compartment, driven by the crankshaft via a serpentine belt. The LIN, on the other hand, is a communication protocol that enables various electronic components, like the alternator and battery sensor, to exchange information efficiently. If this connection is disrupted, the DTC is stored and may affect overall engine performance. Before proceeding with the diagnostic process, it is essential to review relevant manuals and potential causes for this issue in detail. DTC P16E2 signifies a communication failure between the alternator and the PCM due to issues within the LIN circuit. The PCM monitors the performance and function of the alternator by receiving signals pertaining to voltage and operational status through the LIN. Any disruption in these signals indicates a failure in communication. The involved components are the PCM, which is usually located within the vehicle's cabin, and the alternator, which is situated at the front of the engine bay. The LIN circuit itself is connected to the alternator and the 12-volt battery sensor, which enhances communication efficiency. Understanding each component's placement and role is crucial for effective troubleshooting. Miscommunication can potentially lead to suboptimal charging of the battery and impaired electrical system performance. Several causes can lead to the occurrence of DTC P16E2. The primary suspect is often a loose terminal connection at the alternator, specifically the ACG plus B terminal. If this terminal is not secured properly, it can result in communication errors being detected by the PCM. Additionally, a faulty alternator itself may fail to send correct signals, which will also cause DTC P16E2 to be triggered. Wiring issues within the LIN circuit are another potential cause. Damaged or shorted wires can disrupt the communication path, leading to the PCM not receiving necessary data. Each of these factors must be carefully examined during the diagnostic process to isolate the source of the error effectively. Failure to rectify these issues could adversely affect vehicle performance. When DTC P16E2 is present, several symptoms may manifest, indicating underlying electrical problems. One of the most significant concerns is battery charging issues. If the alternator signals are not relayed properly to the PCM, it may lead to insufficient battery charging. This inadequacy can also result in various electrical system malfunctions, as numerous components rely on a fully charged battery. Drivers might notice warning lights on the dashboard, such as the battery light, indicating that the alternator may not be functioning correctly. Additionally, engine performance may deteriorate due to a lack of adequate power supply. Understanding these symptoms is crucial for timely intervention and resolution of the issue, potentially avoiding more severe problems. The first troubleshooting step in diagnosing DTC P16E2 involves turning the vehicle's ignition to the on mode and waiting for 10 seconds. This initial action helps to bring the vehicle's electrical systems online, allowing the PCM to reset and establish communication with the alternator through the LIN circuit. It is essential to ensure that all components connected to the LIN are in their proper positions during this process. By performing this simple but crucial step, any temporary glitches that might cause communication issues can often be resolved before more in-depth diagnostic work is required. After waiting, the next steps would involve checking for any stored DTCs that could provide further insight into the issue's root cause. In the second troubleshooting step, focus shifts to the alternator connection, specifically inspecting the ACG plus B terminal. The ACG plus B terminal is critical for the alternator's operation and directly linked to the LIN communication with the PCM. If this terminal is found to be loose or corroded, it could result in the proper signals not being transmitted effectively, leading to the DTC P16E2 being triggered. Performing a thorough inspection at this point includes verifying that all connections are secure and free of any physical damage. If issues are discovered here, they will need to be rectified before proceeding with additional troubleshooting procedures. This step often resolves the DTC and is a straightforward check that should not be overlooked. Next, the third troubleshooting step requires an inspection of the alternator's functionality. This involves conducting tests to ensure the alternator is performing its intended role of generating electrical power effectively. If the alternator's internal circuit is faulty, it may fail to send appropriate voltage back to the PCM, leading to the DTC P16E2 code being stored. To perform this inspection, disconnect the alternator and conduct a test to verify its operation under load. Ensure that the alternator does not exhibit any signs of shorting or other operational failures. If abnormalities are detected during this section of the inspection, further diagnosis or replacement of the alternator may be warranted. This thorough assessment is vital to ascertain that the alternator is indeed functioning optimally. The fourth troubleshooting step focuses on inspecting the LIN circuit connection and the components connected to it. This circuit is responsible for facilitating communication between the alternator, battery sensor, and the PCM. Disruption or faults in this circuit can result in DTC P16E2 being recorded. The process begins with verifying that the LIN circuit is intact by checking for shorts or opens in the wire that could affect communication. Each connected component should be tested individually as well. If any connected device, such as the 12-volt battery sensor, is malfunctioning, it may hinder proper communication with the PCM. Identifying and addressing faults in the LIN circuit is crucial to restore accurate communication and resolve the error efficiently. In the fifth troubleshooting step, the focus turns to the PCM itself. If all preceding components and connections have been inspected and found to be functioning correctly, yet the issue persists, it may indicate a problem with the PCM. The PCM, or Powertrain Control Module, serves as the vehicle's brain, managing data from various sensors and controlling engine performance accordingly. A malfunctioning PCM might not be able to interpret the signals being sent by the alternator accurately. To investigate this, diagnostic checks can be performed to evaluate the PCM's performance and look for any error codes that may provide insights. If faults are confirmed in the PCM, replacement or repair would be the necessary course of action. This step is vital, as it validates that the control unit is operating efficiently within the vehicle's electrical framework. After completing the necessary repairs or component replacements, the final verification step entails clearing any stored DTCs from the PCM and conducting a test drive. Clearing the DTCs ensures that any previous codes do not interfere with new diagnostics. Following the reset, it's crucial to take the vehicle for a test drive to allow the PCM to re-establish communication with the alternator through the LIN circuit under real-world driving conditions. This step validates the repairs made have been successful and confirms that no further DTCs are triggered post-repair. Monitoring the vehicle's performance during the drive will help ascertain that all systems are functioning correctly and any irregularities can be quickly addressed. Final verification is vital for ensuring long-term reliability and performance of the vehicle. To prevent the occurrence of DTC P16E2 in the future, implementing a regular preventive maintenance routine is essential. This routine should start with periodic inspections of all electrical connections, especially at the alternator and related components. Over time, corrosion or looseness may develop, impacting the efficacy of the connection and communication. Furthermore, it is advisable to service the alternator periodically to examine its performance and ensure it operates efficiently. This includes checking the internal circuits and output voltage. By staying proactive with these maintenance practices, the likelihood of unexpected DTCs arising concerning the alternator and PCM communication can be significantly reduced. Maintenance not only enhances reliability, but also extends the lifespan of critical vehicle components. In summary, DTC P16E2 indicates a communication error between the PCM and components such as the alternator through the LIN circuit. Identifying loose connections, faulty components, and damaged wiring is crucial for resolving this error effectively. Each step in troubleshooting, from inspecting the alternator to testing the LIN circuit and PCM, is vital in pinpointing the underlying issue. By acknowledging the potential causes and understanding symptoms, diagnostics can lead to a comprehensive repair process. Moreover, implementing preventive maintenance practices is essential to minimizing future occurrences of this DTC. Staying vigilant and proactive in vehicle care will ensure reliable performance and a longer lifespan for the engine management system and electrical components. Please like and subscribe to the channel. See you next time!